E agora, já está a funcionar? Também não? Alguém tem o som ligado? Já está? Ok. Isso, obrigado. Ok, então, PSR parte 2. O que é que nós vamos fazer? Vamos continuar a fazer programas em Python, ainda sobre o cálculo dos primos. Na verdade, vamos para números perfeitos. E só para terem uma noção de como é que devem organizar as coisas, já vos falei um bocadinho nisso, mas tenho aqui algumas diretivas gerais. Ao fim e ao cabo, cada aula, vocês devem ter uma pasta de PSR, claro, e depois cada aula será separada em aula 1, aula 2 ou parte 01, parte 02, o que vocês preferirem. E depois lá dentro, cada exercício deve ser também uma pasta, e depois lá dentro com um ou mais ficheiros Python. Tipicamente, eu como não tenho muita criatividade para dar nomes às coisas, tipicamente o que eu chamo aos meus exercícios são sempre x1 e depois aos meus ficheiros Python chamo-lhes tipicamente sempre main.py. Aqui ainda estava, eram os primeiros exercícios, ainda arranjava a maneira de dar um nome parecido com aquilo que o exercício pretendia fazer, ok? Mas basicamente então, eu estou aqui na parte 01, estou na aula teórica, isto é teórica, não é TP, portanto vou mudar isto para T, e depois aqui vou fazer, por exemplo, o exercício 1, é x1. Esta camada, este nível hierárquico da teórica e por aí fora, a vocês não vos interessa. A mim existe porque eu às vezes faço experiências na teórica, experiências na prática 1, experiências na prática 2, às vezes faço o mesmo exercício em vários sítios e por isso é que tenho que arranjar aqui mais uma diretoria para separar. E depois cá dentro, obviamente, vocês têm um fecheiro que eu vou chamar main.py, chamo-lhe sempre main.py, e aqui vocês têm que ter, digamos, o ponto de partida base para um código Python, que tipicamente é isto. Então, nós temos uma função main. Ok? Aqui é onde nós vamos escrever o nosso código. E depois este if, ao fim e ao cabo, vai verificar se este ficheiro foi chamado diretamente do terminal. E se tivesse sido esse o caso, o nome dele, este underscore, underscore, name, underscore, underscore, é uma variável interna que o Python se encarrega de preencher. E se realmente este ficheiro tivesse sido chamado diretamente do terminal, o que vai acontecer é que o nome dele será underscore, underscore, main, underscore, underscore, e por causa disso ele vai chamar a função main. Portanto, se eu puser o meu código dentro da função main, ele vai ser executado. Isto é um bocado rebuscado, quer dizer, não é direto, não se escreve logo o código, mas tem vantagens em particular para não termos variáveis globais. Depois também já vos falei da shebang line, que é uma linha de código que se põe aqui e que faz com que o Linux perceba que quando chamamos este ficheiro, ele será interpretado com o interpretador de Python 3, e isto evita que nós tenhamos que chamar o ficheiro desta forma. Deixem-me abrir aqui o meu caminho, abrir um terminal aqui à esquerda, à direita, cd paste, portanto já estou exatamente no sítio, nada. E, deixem-me só pôr isto aqui. Portanto, vocês aqui estão na pasta do terminal e se quiserem arrancar com este código, vamos só escrever aqui qualquer coisa para vermos que o código faz qualquer coisa, print hello PSR. Okay? Portanto, se eu correr isto Python main, ele diz-me hello PSR. Só que é uma chatice, está sempre a escrever Python 3 main, Python 3 main. A melhor maneira é usar esta shebang line que indica dentro do próprio ficheiro como é que ele há de ser interpretado, com que linguagem. E faz com que eu possa chamá-lo desta forma, ./main, quer dizer, o ficheiro que está na diretoria atual é isso que é o ponto, e o main é o nome dele. Para que ele seja executado, temos que lhe mudar as permissões, eu já vos falei nisso, portanto eu tenho que fazer um chmod 777 do main.py. 777 é para dar as permissões todas, ele pode ser lido, escrito e executado por toda a gente. Portanto, agora sim é que eu posso correr o main.py. Okay? Portanto, isto é, digamos, o ponto de partida base. Se quiserem até podem guardar este modelo, como seja um snippet ou um template, para sempre que vocês vão começar a programar. Quando tiverem dúvidas, vão perguntando, ok? Estejam à vontade. Deixa-me só vir para aqui. Então, o que se pretende fazer aqui no exercício 1 é copiar o exercício dos números perfeitos e colocar comentários. Ora, nós não chegamos a fazer o exercício dos números perfeitos, portanto eu vou fazer o exercício dos números perfeitos, ok? Portanto, a ideia é conseguir perceber, dar um número máximo. Eu vou, por exemplo, dar copiar aqui esta linha. Portanto, há uma variável global que será o número máximo até o qual vamos testar a ver se os números são perfeitos. E depois aqui, o que nós temos que fazer é, para ver se os números são perfeitos, percorrer desde o 1 até ao máximo, neste caso o 100, e perceber se os números são perfeitos. Eu não sei se está toda a gente ciente do que é o número perfeito. O número perfeito é um número cujos divisores, cuja soma dos seus divisores inteiros é igual ao número. Por exemplo, o 6 tem o divisor inteiro 1, o divisor inteiro 2, o divisor inteiro 2 e o divisor inteiro 3. 2 mais 1 mais 3 é igual a 6. Okay? Portanto, o 6 é um número perfeito. E depois há uns tantos, que eu já não sei quais são, mais à frente, que são também perfeitos. Portanto, o que nós precisamos de fazer é então calcular os divisores inteiros desses números. Portanto, primeiro vou percorrer todos os números. For number in range, eu vou desde o 1 até ao maximum number. Ok? Portanto, eu com isto estou a print analyzing number e aqui vou imprimir o valor do número. Depois, vou precisar então de perceber se este número é perfeito ou não. Então, vou criar uma função chamada isPerfect. Esta função vai receber o número, number, e vai depois retornar verdadeiro ou falso em função do número ser perfeito ou não. Então, eu vou dizer assim, returns true if number is perfect, false otherwise. Okay? Portanto, isto é o que nós pretendemos que a função faça. E então, para nós agora percebermos se, por exemplo, esta estrutura de código está a funcionar, nós podemos, para já, dizer que os números são todos perfeitos. Portanto, eu posso dizer assim, return true. Assume all numbers are perfect. Isto é só, digamos, um teste intermédio para ver se a estrutura do código está a funcionar. E agora preciso de chamar aqui a função isPerfect. Portanto, if isPerfect do number, ok? Portanto, se o resultado da chamada da função isPerfect com o argumento number for verdadeiro, eu vou imprimir assim, number, ou se calhar ponho só o número, que é isto, str, number is perfect. Else is not perfect. Ok? Faz sentido a toda a gente? Mais uma vez, vão interrompendo, porque quando não me dizem nada, eu acho que estou a ir devagar demais e começo a acelerar. Então, se eu correr este código, já sabem aquele truque de fazer o clear primeiro para limpar o ecrã, se eu correr este código, o que acontece é que ele vai analisar os números todos até ao 99, vencer até ao 100, portanto eu vou pôr aqui até o maximum number mais 1. Portanto ele agora sim analisa até ao 100. Diga mais alto. Porquê é que ele analisa ao 100? Porque quando você usa aqui esta função, o range dá-lhe um intervalo, dá-lhe um conjunto de números inteiros, no intervalo de 1 até ao máximo, o intervalo à esquerda é fechado, o à direita é aberto. Okay? Pronto, e ele aqui fez exatamente o que estaríamos à espera, quer dizer que os números são todos perfeitos. Okay? Vamos só pôr isto até 10, para ser mais fácil de analisar, escusamos estar a ver sempre os números até 100. Então, temos aqui até 10, e agora só precisamos então de preencher o que está na função isPerfect, para vermos se os números são ou não perfeitos. O que é que nós podemos fazer para ver se os números são perfeitos? Como eu vos disse, um número perfeito é aquele cuja soma dos divisores inteiros é igual ao próprio número. Portanto, uma primeira funcionalidade que nós precisamos de conseguir implementar é calcular os divisores inteiros de um número. Okay? Portanto, eu vou fazer uma outra função chamada getDividers. Esta função vai buscar os divisores inteiros de um qualquer número number. Então, como é que nós vamos fazer isso? Tal como fizemos a semana passada, nós, para um determinado número, nós vamos ter que percorrer desde o 1 até esse próprio número. Portanto, eu vou novamente fazer o for e in range desde o 1 até ao number. E reparem agora que eu estou a excluir o número porque o number é um intervalo aberto, portanto eu não vou até ao number, vou só até ao número menos 1. E é isso mesmo que eu quero. Por exemplo, para o 6 eu quero testar o 6 a dividir por 1, o 6 a dividir por 2, por 3, por 4, por 5 e não quero dividir por 6, ok? Portanto eu vou desde 1 até ao number e para cada um deles vou verificar se o número módulo de i é igual a 0. O que é o número módulo? Semana passada, mas eu explico outra vez. O número módulo de i, sobretudo este operador que se chama módulo, a percentagem, o que faz é devolver o resto da divisão inteira. Portanto, por exemplo, se eu dividisse o 6 por 1, 6 a dividir por 1 é 6 e o resto 0. Portanto, o 6 a dividir por 1 daria 0, o resultado desta operação number percentagem i. E por aí fora, ok? Portanto, isto devolve, returns the remainder, deixa-me por aqui. Hello, good morning. Go ahead. Yes, please. No problem, you told me so. Esta colega iraniana, I'm just asking them if I may speak in English, because I didn't speak to them before. Esta colega iraniana, please sit. Esta colega iraniana pronto, e está a fazer o curso também, a cadeira também. A minha pergunta é se vocês têm algum problema que eu fale em inglês. Eu pergunto sempre isto, mas se houver alguém que esteja mais ou menos à vontade, tem que estar à vontade para o dizer agora. Caso contrário, eu falo em inglês, a mim não me faz muita diferença, um ou outro. Claro, vou mandar umas trancadas no inglês, mas vocês não perdoam-me. Posso falar em inglês? É isso? Ok, so, where are you? Okay. They don't mind that I speak in English, so you are very lucky. You can thank them afterwards. So I will switch to English, and in these classes I can speak in English, okay? In any case, if any of the colleagues have a problem with me speaking English, you are free to say so. You can send me an email or something and say so, because these classes are meant to be spoken taught in Portuguese. So you can tell me, oh, I prefer Portuguese, it's much better for me. And that's okay, okay? So if you don't feel comfortable, send me an email afterwards. For this class, I can speak in English. So we were trying to use the modulus operator. Is the modulus operator, which returns, which returns the remainder of a division, of an integer division. Ok? Portanto, retorna o resto da divisão inteira. Então, e se eu fizer isto, para cada número i está abaixo do número number, sorry, in English, if I do this for every number I, which is below number, what will happen is that I can check which are the integer dividers of the number. And so I could say something like this. I could say something like this. stri is an integer divider of, and now I put here my number, str number. Okay? So, for example, if I run this, something went wrong. Okay, so I need to call the function, of course. So now, when I call is perfect, I will call get dividers with the variable number here. Okay? So now I get analyzing number 1. Number 1 is perfect. Okay. Analyzing number 2. And I say 1 is an integer divider of 2, which is good, and 2 is perfect. All numbers are perfect for now. And then, and so on and so forth. So you can see, for example, for number 3, the program only said that number 1 was an integer divider. It passed through number 2, but 2 is not an integer divider, so it didn't print so. Okay. So we are making progress. Now we have a print here, which will print whenever I find an integer divider of the number. The question now is that I need to store all the dividers, okay? because then I will need to sum them. So either I sum them on the fly, or better still, I will create a data structure which will contain all the dividers of a given number and then return this list. In Python, we have special data structures which are very powerful. One of the most powerful ones and most interesting ones, and actually most used ones, are the lists. So lists are groups of things, and these things can be very different between themselves. For example, let me turn on here an interactive console. I don't know if clear, yeah, an interactive console here. And if I say A equals 3, A is a variable which is number 3, it's a scalar. If I say A, actually, whenever it's a list, it's a set of things. So typically I use the plural. So let's call it AS for plural. Then I open the brackets, parênteses, and I put their stuff 3, 4, 5. So this is a list. AS is a list of numbers 3, 4, 5. Of course, you can also do lists in many other languages. For example, C, C++, actually in C, no, but in C++, yes. The problem, what's interesting in Python is that lists will be able to contain data which is completely different. So, for example, rather than having to store only numbers, I can store for the second element of the matrix the string which contains the name of the number. Okay. So in a list, I can put everything. It's a group of things, and these things do not have to be all of the same type. It can be whatever you want. Okay. We will learn a bit more in the next class about data structures for Python, including lists and also dictionaries. For now, let's stick just with this small explanation of what are lists in Python, because we will need to create a list of dividers. So dividers will be the name of my variable, again, plural, because I am creating a list, and now I'm going to create an empty list. So when I do open close brackets, it means this is a list with nothing inside. And then whenever I find an integer divider of the number, what I will need to do is to add a new number to that list, and this is called append. So dividers dot append to the list, and I will append number I. Okay. So with this instruction here in line 12, what will happen is that the dividers list will grow. It will have a new integer divider, and then another, and then another. Okay. So instead of printing, so now I can print after I compute for all the numbers below the number. So after this for loop is finished, I can say something like this: number has dividers, and now I will print the list of dividers. Okay, so Python is nice also because it can print directly lists. Okay, so if I run this, look at what happens. Let's start with number 6, for example. It will say something like this: number 1 is an integer divider of 6. Then it goes to number 2, it's also an integer divider of 6. Then it goes to number 3, it's also an integer divider of 6. And then it goes to number 4 and 5, and those are not integer dividers, so it will not print that. And in the end, it says 6 has dividers 1, 2, 3. Okay, so we are creating a list of the dividers of number 6. And to finalize this function, so first we can comment this print because we will not need it. And also this one, we can comment it. So to finalize this function, what we need to do is to return the list that we've computed. So return dividers. All right? So this function will actually get the dividers. It will iterate all the numbers below the number, see if these numbers are integer dividers of that number, compile a list of the integer dividers, and then return that list. Okay? So now we can get here, when we are calling the function on line 21, we can actually get the dividers, because now they are being returned on line 16 from the function. So what can we do now? We can create a new variable, which doesn't have to have the same name, but I will call it the same name: dividers equals get dividers. Okay. So now inside the isPerfect function, we have a variable called dividers, which contains the dividers for the number. You are also silent. I start to get worried when this happens. O ponto append? Yeah, sure, I can. So, interactive Python console. I told you before that A is a number. Then I said, let's do a list of numbers, right? 3, 4, 5. Now, what if you want to add number 6 on the end of the list? You can say as.append 6. And AS will be 3, 4, 5, 6. So append will put a new element at the end of the list. Okay, so what's happening here is something like this. My dividers is an empty list. So for now, dividers is nothing. Then I will, for example, for the number 6, I will divide 6 by 2. And it will say, oh, 2 is a divider, an integer divider of 6. So it will say dividers dot append 2, because this is one divider. So now my dividers is 2. Then I will go to number 3 and divide 6 by 3 and find out that 3 is also an integer divider of 6. So now I will say dividers dot append 3. So now my dividers list is 2, 3, and so on and so forth. You get it? Yeah. Sure. Can you ask your colleague, João? João, can you send her the Zoom link, please? Thanks, João. All right, so now that we have the dividers, what can we do? As I told you before, a perfect number is a number. Yeah, go ahead. Yes, we could, but that's let's say bad practice. Global variables are variables that, as the name says, are accessible on all the functions. And this is not good from a programming point of view. Why? Because whenever you have global variables, you have the risk of interference between one part of the code and another. So the reason why you do functions, and actually why you always try to avoid global variables, is exactly in order to have your code as independent as possible. So you have this module which does not affect the other, unless in a specific place where you say, copy the result of this function to that variable. So global variables are not desirable, they are the opposite. You want to run away from them as much as possible. I do have a global variable here, this one, but that's because of something that will appear next week. So I want to change that one to something else, okay? So actually this global variable didn't have to be global. If you take a look at it, it's only required in the main function, right? It's not used in the get dividers nor in the isPerfect. So you could actually put it here, right? So the answer to your question, why didn't you use global variables, is the following: because I'm trying to program correctly, right? So now that we have the dividers, and we know that a perfect number is a number whose sum, which has the sum of dividers equals to itself, how can I check if this number is perfect? Who can tell me? All right, so I can call it total sum dividers. Sorry again?
These sum dividers wouldn't work if we had a string like.
Right. If the list has something like this, so dividers.append. Hello. Dividers. Of course, it will not work, the sum, but we know that this is not going to happen. So we can just assume that all our list will only contain numbers, therefore the sum will work. Okay. So yes, we sum, but that's not it, is it? So I still didn't make it. Exactly. So if total equals number, then the number is perfect. If the number is perfect, this function should return true. Oh, sorry. If it's not, the function should return false. Right? 3DD. Okay, and that's it. So now we have the complete isPerfect function. Let me just take this away. I don't think we need to create a new variable here. right? So we just sum the dividers, we see if they are the same as the number. If they are, we return true, otherwise we return false. And now we have a way of checking if the number is perfect or not. Notice that now the isPerfect function is already returning whether or not the number is perfect. So we can take a look at these prints and see if they make sense, right? So let's try to see if they make sense. Well, actually, for that, I would need to know which are the perfect numbers. So perfect numbers. Is there a list here of perfect numbers? Gosh, I don't. Six, 28, 496, I think, right? Just a moment, let me see. List of perfect numbers. Okay, so we will trust it. I cannot find the list of perfect numbers. So let's try it. So it says here, number 1 is not perfect, number 2 is not perfect. The only perfect number is number 6, right? Makes sense. Then all the others are not perfect. But we can go forward. I know 28, I think, is perfect, right? So let's not go until number 10, but let's move forward to, for example, 50 or something, just to see if 28 is correct. 28 is correctly identified. So 28 is perfect. It seems to be working, right? So I think there are no more perfect numbers. But that's not the problem. Our code is perfect. The numbers are not, but the code is quite nice now. Okay. And that's it. Nothing special. We created 2 functions. We could have created no function at all. It depends many times on the taste of the programmer. There are some guidelines, of course. For example, not using global variables, not creating functions for things that are very, very simple. In this case, these things are simple, but nonetheless, I wanted to teach you how to use functions. So I think it makes sense to create functions here. Any questions about this exercise? No? All right, so let's jump into the next one. I think that's, yeah. Okay, commenting. So how do you comment code in Python? If you're using Visual Code, you can do like this. So you do 1, 2, yeah. If you do aspas, how do you say aspas? I never know how to say aspas. So if quotes, yeah. If you do quotes twice, 1, 2, 2, it says, do you want to generate docstring? Docstring is the format which is used to comment Python. So immediately, Visual Code created something for you like this. So whenever you have underscores, that means you have to replace. So this function gets the integer dividers of a number. So this is like a summary of what the function does. Now the arguments will have a type. So notice that Python is it's not a strongly typed language, so you don't have to say this variable has this specific type. In any case, you can specify, and this will help the Visual Code help you. So you can say here that what we need is to give an integer number. So this is an integer, a number to test, okay? And then the return will be a list, right? And a list of dividers. Okay? So this is how you go about writing comments in Python for your functions. There are many styles. I think Google uses a different one. This is the docstring format. I will recommend this since this is out of the box in VS Code. Okay, so try to use docstring to comment code. I don't enforce a lot of code commenting because we are going to use RAWs, and in RAWs, more than having the code well commented, the best is that the code works and you don't have to look at the code of your partner. So if the code works, I don't care if it's commented or not, because I'm never going to look at it. I just want to interface with that code. And for that, more than the comments, what I need is a good README, okay? So a good README is paramount to the quality of the code nowadays. Okay. So I can show you a README where you can Rustbot, for example. Guitar. Wait. Let me go to a code just to show you how you can do some comments. So, for example, I always have a problem with finding stuff. Okay, so for example, this one. So this is a code to do something, and then I have a picture just to try to show what it does. And then we have a table of contents. For example, you want to know how to visualize, you click here and you go there directly. And then typically you have always some very nice instructions on how you can use the code. Okay, this is a special example. I put a lot of code here because this is a library. So this shows you how you can use the library. But typically you just say, oh, I want to launch this like this. Another example. I can give you another example with Rustbot. I just have to find it. Rustbot. Okay. So one example here. So this was a robotic system which contained 2 cameras. So this was a stereo system mounted on top of a gimbal, which is a motorized system to stabilize the pointing of the cameras, like a chicken head, right? If you move the chicken, the head will always be on the same place. And here you can see the README. It contains a lot of instructions, and then it tells you, oh, if you want to run this, just copy this line to the terminal and run it. Okay. So more important than code commenting is README, writing the nice READMEs for people to use our code nowadays. Yeah.
I've seen that on your report you have READMEs on .adoc, and this one is on the
MD. Well, this is I used adoc because it was more interesting. Well, actually, because I based this on something from another professor, and he used adoc, so I tried to use it. And the PSR READMEs are all adocs. But for example, for the other courses, I already use MDs, which are the standard on GitHub, and I think it's more than enough, mostly. So I wouldn't go to adoc, I would just use MD, Markdown language. What else? Exercise 2 talks about how you can split a code into different files. So sometimes when your code starts growing a lot, it's interesting that you have many different files where you can put different things. In this case, so I will just copy exercise 1, copy, paste. Where did it go? Copy. Well, wait. Exercise 1. Here it is. So let me just put it here again in theoretical. Não consigo pôr isto aqui. Ah, já está, ok. Okay, so this is the code that we had before, but now it's called exercise 2, ex2. Now, if we want to split this into several files, let's create a new file. So I will go here and I will copy paste, and I will change this to my functions. So let's say that we will have 2 files, one called main and the other containing the functions called my functions. So now what I need to do is the following. On the main, I need to take away the functions. And on the my functions, I need to take away the main. Now, notice that this shebang line, the first line, I told you, is to let Python know how a file can be executed. My functions will not be executed directly. So I'm not going to call from the terminal /myfunctions.py. I will always call main, which will use my functions. So the shebang line is not needed for Python modules, which are libraries. Okay. So I just need to state the functions. Now, in order to, so now you can, if you go back to the code, you will see immediately that it's saying, oh, I don't know what isPerfect is. So the code is, the Visual Code is complaining, saying, you are trying to use a function here, which does not exist. Of course, because I didn't tell the code that it should go get the isPerfect function from the myfunctions file. How do I do that? I do it like this: import, from my functions, import isPerfect. Okay. So with this, I'm importing just one function called isPerfect from my functions file. I could do this in some other way, which would be an alternative like this. I would say import my functions. Okay, so alternative 1, alternative 2. What's the difference between 1 and 2? The difference is that in alternative 1, I am importing everything that is in the file. So if the file has 1,000 functions, I will import them all. My code's memory footprint will grow. Whereas in the case of the second alternative, I'm importing just one function from that file. It can have 1,000 functions, I will only pick up one. Okay. So it's recommended that you use alternative 2 whenever possible, which is the one I'm going to use now. I think it should work. Let's try. So now we just have to try to see if it works, right? Let's see. So I'm going to go back to my terminal. I have to change the directory because now I'm on exercise 2. You can see here that I have two files, main and my functions, but I just have to run main, of course, with a clear before. So you can see that it continued to work without a problem. So it still says 6 is perfect, blah, blah, blah. So exercise 2 is just about reshaping and creating two files instead of one. Okay, this might be useful for you when the code starts to get complicated. So we have 10 minutes. We will continue on the practical classes. Okay, so it says here on the exercise 3 that we should change the previous exercise in order to get an entry parameter, which is the maximum limit. And this is done using the argparse function. So now we start using one of the biggest advantages of Python, which is to start using other libraries. So Python has an amazing set of libraries developed by other persons that we can use. And it's quite easy to use. How do we do it? So if you go to the links, typically we just search online and we can find argparse. And then it typically says how you can use. So what you have to do is import argparse. Okay. So for example, for my exercise 3, which I'm going to copy paste here, ex3. So let me just quit all of these and open the main from exercise 3. So I just have to import, copy the argparse. Okay, so there it is. This is about importing a library, import argparse library. So yes, in this case, I'm using the alternative 1. So I'm importing every function that is inside argparse. I don't want to have the trouble of figuring out which functions I need and specifying them explicitly. So I'm just importing everything. And one thing that may not work in your case, if you are trying to do this in your computer, is that these libraries sometimes must be installed. So sometimes you don't have these libraries. If you do not have them, whenever you try to run the code, it will say, I don't know what argparse is. And for many of these libraries, what you must do is sudo pip install and the name of the library, argparse. So in my case, I have to do sudo pip 3. In your case, I think it's sudo pip is enough, but you can try sudo pip 3 as well. Pip is a software inside Linux that will install, that is a way to install new packages for Python specifically. And then you say install because you want to install, and argparse because you want to install this particular library. It will always ask you for the password. and then it will say, in my case, okay, I installed it, no problem. Okay. So you should install the argparse, and then in order to use it, you have first this, the import, and then you have to use the functions. Here it says how. Okay. So let's see. I will copy and then adapt. That's what I always do. So look at the examples. So you need to create first the argument parser. Okay. And the argument parser will be this parser. Okay. This description, test PSR, test for PSR. Then we are going to add a new argument. So I just have a single argument. I'm going to put one. This argument will be called what is it? Maximum number. Yeah, maximum number. Okay. So I have here argument maximum number. I can say that it's of type int, and this is not important. I can just put the help. Yeah. Para o método já vi os argumentos pré-preenchidos. Eu copiei daqui, da net. Eu fiz copy paste da net. So now this is just about, so this argument in particular, the maximum number, until which we check if numbers are perfect. Okay. Okay, so after this, we do here these args, and finally, we can let's print these args. Print args. I think I have to do something here that is missing. Okay, so now we are not seeing anything, because let's go until number 1 only, or 2, so that these prints are not going to in the wrong place. CD exercise 3. I changed directory main. Okay. So look, the first thing that it says is, hey, you need to tell me the maximum number as an argument. So this argparse functionality is nice because it will keep track of the arguments that you want to use. So for example, if I say here require equals false, I'm saying this is an optional argument. And if this is optional, now I can run the code without specifying the maximum number. Okay, so it worked. It failed ahead, but that's not the issue. Now, if you want to make sure that you need this argument, you will say required true. Required is I remember this required existed. Find required. Yeah. I don't know why the required is not working. Required true, tá aqui. Add argument, blah, 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 required true. What's the problem with os dois tracinhos? Não costuma ser isso, mas deixa-me comentar. Será isso? É isso mesmo, obrigado. Okay, so now this maximum number we have to specify. Otherwise, the code will always say, oh, you cannot run this code without specifying the maximum number. So now I say minus minus maximum number 3. And it will say, okay, the maximum number is 3. Now, this args here, how can I extract the variable from the args? I can extract it using something called, I think it's values. Let me check. I never know this. I don't know. Well, in any case, I can. Let me check my code. Just a moment. I always forget how to do this. So if I go, for example, to the calibration code and to atom calibration, calibrate And here we have the main, blah, 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 blah. Vars. Yeah, I have to put these vars. I always forget these vars. So we go back to Savi. No, not Savi, PSR. We go back to PSR. So we are in the same place. Let me just open the file. Part 02, exercise 3. Main. We are in number 4 already? No. Cara, turma passar aqui, não é aqui. Part 2, teórica. Okay. So we are back in the same place, and now I know how to do this because we had to do this vars. What's the advantage of doing these vars? Is that if we do this, you will see that the print that I'm doing here, so whenever I do print args, it will return curved brackets, chavetas, then a pair with a string called maximum number 2.3. What is this? This is a Python dictionary, okay? So this is a data structure which is very standard in Python. That's why the vars is important, because it converts the arguments to this special data structure. And for now, I will not spend time on talking about it because we will discuss it next week. But this is very easy to use now, because now my maximum number will be the args. And because now args is a dictionary, I just have to specify the key of the dictionary that I want, like this, okay? So now I can remove this, and I can specify the maximum number directly when I call the code, okay? So for example, if I now say maximum number 3, it will run until number 3, the analysis. If I say maximum number 30, it will run until the analysis of number 30. And if I don't say anything, it will say, you have to say something, okay? So this argparse library is very interesting for you to customize the way that you execute your script by giving it extra arguments to parameterize how it will work, okay? Okay, 10 o'clock, that's it. Any questions? No? Okay, so. Yes. Yes. Okay, let's meet in the practical classes, okay? Thanks.